Good morning. Today our topic is chemical properties of carbon compounds. Following are some general instruction regarding to this topic. I will take this topic next 20 minutes continuously. You can take notes while I am explaining, and if you have any doubts, you can write it in your notebook or in the chat box. I will address those doubts after this section. If you have any emergency situation during the class, you can press hand button in the menu bar. If I ask some question, the respective person can answer the question. If you understood, you can put thumbs up after each topic. Shall we start? Please show thumbs up. In this section, I'll explain some of the chemical properties of carbon compounds. It includes mainly four properties: combustion reaction, oxidation reaction, addition reaction, and also substitution reaction. Before this section, I will explain some of the basic concepts or terminologies related to this topic. I think we have already studied in the previous section. Just to recap these topics. We know that there are major 7 functional groups in this portion. So, halogen, alcohol, aldehyde, ketone, carboxylic acid, alkenes and alkyne as the 7 functional group. First function group is halogen. Here we write prefix as chloro, bromo like that. What is mean by prefix? Prefix which means something add before the name is prefix. Example, consider Sri Ram. Sri is the prefix and Ram is the name. Saint Joseph. Saint is the prefix and Joseph is the name. Here, halogen family, we example chloropropene. Chloro is the prefix and propane is the name. And other example, bromopropane. Bromo is the prefix and propane is the name. Next function group is alcohol. Here we write as a suffix as all. What is mean by suffix? Suffix which means something add after the name is called suffix. Example, consider Priya Menon. Priya is the name and Menon is the suffix. Mallu Singh. Mallu is the name and Singh is the suffix form. So here propanol. Prop is the name and all is the suffix form. Next example, ethanol. Ethane is the name and all is the suffix form. Aldehyde. Now aldehyde we write a suffix as al. So propanol is an example. Prop is the name and all is the suffix form. In ketone family, we write suffix as on. So propanol is an example, prop is the name, and on is the suffix form. Next function group, carboxylic acid. Here we write suffix as oic acid. So an example, propanoic acid. Prop is the name and oic acid is the suffix form. Next function group is alkenes. Here we write suffix as e. So example, propene. Prop is the name and ene is the suffix form. Last function group in this section is alkynes. We write suffix as ine, propine. So an example, prop is the name and ine is the suffix form. I think we have already studied in hydrocarbons, 2 types, saturated and unsaturated condition. In saturated condition, we say it's take place in single bond. In unsaturated condition, so least one double bond or a triple bond, or in a ring in its carbon compounds. So I'll explain what's the difference between saturated hydrocarbons and also unsaturated hydrocarbons. Saturated and unsaturated. In saturated hydrocarbons, we say single bond. Single bond we show as a single line. In unsaturated condition, we say that is a double bond. Double bond. In triple bond. In double bond, we show that a double line, and in triple bond, we say triple line. In single bond is an example, methane. Methane we write as CH4. Carbon with 4 hydrogen. So we write carbon with 4 hydrogen. Next, double bond. We write example CH2 double bond CH2. What is CH2 double bond CH2? Which means ethene. We write double bond in between two carbon and two hydrogen in both carbons. Example for triple bond is ethane. We write ethene as CH triple bond CH. Triple bond in between two carbon and one hydrogen in both carbons. So this is an example for an unsaturated hydrocarbons and saturated hydrocarbons. In single bond we say that saturated hydrocarbons, and in unsaturated condition we say that double bond, and also in triple bond. We came into the main property of this section. First property is combustion. What is combustion? It is a chemical reaction in which a substance burned in the presence of oxygen to give carbon dioxide along with the release of heat and light. Example, consider in our daily life we are cooking food using gas like LPG or a conventional wood burning. The substance burned in the presence of oxygen we give to give carbon dioxide along with the release of heat and light. LPG we uses two types of gas, butane and propane, little bit propane and more in butane. So here we can say an example, carbon react with an oxygen to give carbon dioxide with release of heat and light. In CH, what is CH4? CH4 which means methane. Methane react in the presence of oxygen, we get carbon dioxide and also water and heat and light. In this equation, is not balanced. So I will explain how we balance this equation. For CH4 plus O2 gives CO2 plus H2O. Okay. I will explain how we balance. CH4 plus O2 react to get carbon dioxide and also water and release of heat and light. So we check in both sides of carbon, hydrogen and oxygen. Here we can say how many carbon? We can say only one carbon. How many hydrogen? 4 hydrogen. Oxygen 2. This side how many carbon? We can say 1 carbon. This side how many hydrogen? We can say only 2 hydrogen. And how many oxygen? 3 oxygen. First we check carbon in both sides. Here 1 carbon here and also 1 carbon. So we can say carbon in both sides are balanced. Next we check hydrogen in both sides. Here we can say hydrogen 4 and in this side we say hydrogen 2. So how many less hydrogen in this side? This side we can say 2 hydrogen less. So we add 2 hydrogen this side. What's hydrogen? Here we can say it's hydrogen. So we write 2 in front of hydrogen. So we write 2 in front of hydrogen. 2 into 2, 4. So hydrogen in both sides are balanced. Now we check oxygen in both sides. Here we can say oxygen 2 and here now here oxygen, how many oxygen we can say 1 into 2, 1 into 2, 1 into 2, sorry. One into 2, 2 oxygen. And now and here 2 oxygen and now here 2 oxygen. 2 into 2, 4 oxygen. Now we write here as a 4 oxygen. Now we take oxygen in both sides. Here we can say 4 oxygen. Now here 4 oxygen. How many oxygen left in this side? We can say 2 oxygen. So we write plus 2 in this side. So what is oxygen here? Oxygen. So we write 2 in this side. So 2 into 2, 4 oxygen. In both sides, we can say oxygen is balanced. So this equation is balanced now. Now, other example CH3, CH2, OH. Reactant process of oxygen, we get carbon dioxide and water, release of heat and light. Next, frame characters. We already studied that hydrocarbons are two types, saturated and unsaturated condition. In saturated hydrocarbons, we can say that is a clean flame with blue in color. This is a picture of this flame, saturated hydrocarbons. In unsaturated hydrocarbons, give salty flame with a yellowish color. And second figure shows that an unsaturated condition. I'll explain what's the difference between saturated hydrocarbons in combustion reaction and unsaturated hydrocarbons in combustion reaction. Saturated and unsaturated condition. Saturated and unsaturated condition. In saturated condition, I will say it's a clean flame in blue color. In unsaturated condition, we can say that is a salty flame in yellow color. Example for the saturated condition, we can say LPG. LPG is an example for saturated hydrocarbon. In unsaturated hydrocarbons, we can say an example for burning wood. Burning wood is an example for unsaturated condition. In saturated condition, we can say that it's a complete reaction. Complete reaction. And in unsaturated condition, we can say that it's an incomplete reaction. How we say that it's a complete reaction or incomplete reaction? Because in complete reaction, we can say that it's a sufficient amount of oxygen. Sufficient amount of oxygen is available. So it is a complete reaction. And incomplete reaction, we can say that is an insufficient amount of oxygen. Amount of oxygen. These are the main difference between saturated hydrocarbons and unsaturated hydrocarbons in combustion reaction. It's a clean flame in blue color, example LPG, complete reaction and also sufficient amount of oxygen. In unsaturated condition, we can say salty flame in yellow color, burning wood. It's an example, incomplete reaction and it's an insufficient amount of oxygen. Sorry. In some situation, we can say that saturated hydrocarbons give salty flame because a limited supply of oxygen is the main reason. In particular situations, they show salty flame in saturated hydrocarbons. In unsaturated hydrocarbons give salty flame because carbon content is more than hydrogen content is this, and hence carbon shows incomplete combustion and appears salty flame. So these are the main content in this combustion reaction. Next property of this section is oxidation. So what is oxidation? Oxidation is the addition of oxygen in a compound upon combustion is called oxidation. Here is using as an oxidizing agent. What is oxidizing agent? Oxidizing agent is a substance that oxidizes other substance involved in the reaction by gaining or accepting electrons from them. So in this reaction takes place only in the presence of an oxidizing agent. Here we use as an alkaline potassium permanganate or acidified potassium dichromate. It is an adding of oxygen at that time and is removal of hydrogen. So we studied mainly 2 points in this section. The reaction takes place only in the presence of an oxidizing agent. The name of oxidizing agent is alkaline potassium permanganate or acidified potassium dichromate, and it's the adding of oxygen at that time, removal of hydrogen. These are 2 main points in this section. So example for this oxidation reaction, consider CH3CH2OH. What is mean by in which family OH? OH in alcohol family. So we can say CH3CH2OH in ethanol. Ethanol react in the presence of an alkaline potassium permanganate or acidified potassium dichromate. We get ethanoic acid. How will the reaction take place? I'll explain. CH3, CH2, OH plus O2 gives the presence of an alkaline potassium permanganate, KMnO4. We get CH3, COOH. So here we can say carbon react. In carbon, one carbon we can say 3 hydrogen, and next carbon we can say 2 hydrogen, and next OH plus O2 gives. Here we can say it's an adding of oxygen at that time, removal of hydrogen. We can add 2 oxygen in this place. So we write C with 3 hydrogen and 1 carbon with 2 oxygen and OH. So we can say it's an ethanol. Ethanol react in the presence of alkaline potassium permanganate. We get, ethanoic acid. This is an example for an oxidation reaction. Next example for this is propanol. Propanol reacts in the presence of alkaline potassium permanganate. We get propanoic acid. Next property of this section is addition reaction. What is mean by addition? The reaction in which 2 molecules react to form a single product having all the atoms of the combined molecules are called addition reaction. Here we can say that a reaction takes place only in the presence of a catalyst. What is mean by catalyst? Catalyst which help to increase the rate of reaction or the speed of the reaction. I think we know that there are 3 catalysts. So nickel, palladium, platinum. These are the catalysts. Now we can use here as a catalyst nickel. Nickel catalyst is used in this section. So in this section, unsaturated hydrocarbons is converted into saturated hydrocarbons. In which are unsaturated hydrocarbons? In double bond and triple bond are the unsaturated hydrocarbons. Is converted into saturated hydrocarbons, which are saturated hydrocarbons are single bonds. It's a conversion of double bond or triple bond into a single bond. So in this section, we mainly study 2 points in this, mainly 3 points. First one is it is an reaction take place only in the presence of a catalyst. In which catalyst? Nickel catalyst. And it's a reaction, it's a conversion of unsaturated hydrocarbons into saturated hydrocarbons. It's an adding of hydrogen. Hydrogen is added into an unsaturated hydrocarbons to get saturated hydrocarbons. Example, consider ethene is reacted in the presence of a catalyst nickel to get ethane. I'll explain. Ethene. Ethene we write as CH2 double bond CH2. React in presence of a catalyst nickel. So reactant hydrogen to get this, we get ethane. We write ethane CH3 single bond CH3. How the reaction takes place? So we write carbon the in double bond in between two carbons, and we write two hydrogen in one side and two hydrogen in other side plus hydrogen. We write H2 as 2 hydrogen and react in the presence of a nickel. Here we can say that reaction takes place in the presence of a catalyst. It is an adding of hydrogen. So hydrogen is added. One hydrogen is added in this side and other hydrogen is added into this side. So we write as carbon with 3 hydrogen and other carbon with 3 hydrogen. So this is an ethane form. So ethane is an unsaturated hydrocarbon. It's converted into saturated when ethane is an saturated hydrocarbon. Sorry. Other example of this section is propane is reacted in presence of a catalyst. We get nickel catalyst. We get propane. Some additional applications of this addition reaction. This is a reaction is commonly used in the hydrogenation of vegetable oil using a nickel catalyst. When vegetable oil is hydrogenated, it forms vegetable ghee. What is the use of hydrogenation of vegetable oil? To increase the solid content and also shelf life. This is the use of hydrogenation of vegetable oil. So here we can say that vegetable oil is an unsaturated condition. So it can be converted into saturated one, and saturated condition is vegetable ghee. So here we can say that it's an adding of hydrogen. So vegetable oil is an unsaturated condition. React in the presence of a nickel catalyst to get vegetable ghee as an saturated condition. It is an adding of hydrogen. This is an applications of addition reaction. Now, the last property of this section is substitution reaction. What is substitution reaction? The reaction in which an atom or group of atoms in a molecule is replaced or substituted by different atoms or group of atoms is called substitution reaction. Example, consider Monday 8th period. 7A is an, I think it's a PT period. 7B is a max period. Now max teacher came into 7A and told PT teacher, I will take this class in 7A. So you go to 7B to take class. So there is a substitution. So it is a practical example for substitution reaction. And this reaction takes place only in the presence of an sunlight. So here we can say mainly one point in this section. It is an reaction take place only in the presence of sunlight. In addition reaction, we say that so reaction take place only in the presence of a catalyst nickel, and in oxidation reaction we can say that reaction take place only in the presence of an oxidizing agent, alkaline potassium permanganate or acidified potassium dichromate. However, the reaction take place only in the presence of an sunlight. In alkali hydrocarbons, atoms are replaced by other elements. Here we can say that hydrogen atom is replaced by other elements. So this reaction is a removal of hydrogen and adding of other elements. So it is a substitution. Here example, consider CHCl3 plus Cl2 gives CCl4 plus HCl. How the reaction takes place? I will explain. CHCl3 plus Cl2. React in the presence of sunlight. We show sunlight as H nu. So we write one carbon with one hydrogen and others are 3 chlorine. And we write two chlorine inside react. So here we can study that we think that this is 7A class and 7B class. Now we can say our PT teacher is go to 7B. We consider hydrogen as a PT teacher. So PT teacher is go to 7B. Now we say that 7B max teacher came into 7A. What is max class? So we consider CL is a max teacher. Max teacher is go come to 7A. So this is substitution take place. Is that one hydrogen is go this side and at that time chlorine is go to this side. So we write carbon with 3Cl and we write here as a Cl. So we write here as a Cl. Now in this side we can write hydrogen is go to in this side. So we write as a HCl. So in this reaction we write as CCl4 plus HCl. This is an example for an substitution reaction. Sorry. So, you have any doubts? You can ask now. Thank you.